few polynomials you might already know. So we look at x squared here. Now we can see we've got this, what we've got here at the bottom here, that is what is known as a turning point. Okay, now we're looking for these on all things. So in this one, the power of this would be 2, and there is one turning point. Also, we know about minus x squareds. Okay, so it's upside down here as we see it normally. Okay, now again, the power is 2, but we have still just one turning point. Okay, so it seems to be a general theme. We have a power, the number of turning points is one less. 2, now the power is 3, so it's the power is the highest value that you've got here of the indices, but the turning points is 2. So this theme is carried on. Y equals x cubed. Now that graph looks like this. Now in this situation, the power is 3, but notice in terms of turning points, now you'll find out more about this later, but we notice that it kind of turns here, it kind of slows down and then goes again. So we could argue it's got 1. So this rule seems to be broken. Likewise here, let's have a look. The power of x to the 4, well, in actual fact, we've got power of 4, and the turning points we've got here is, well, 1. It's just 1. From quadratics, where this will go through the x-axis, it's when this would equal to 0. So it's going to go through at 0, go through there. It'll also go through, well, what value of x will make that equal to 0, or 1. So it's going to go through at 1 as well. And we've also got minus 2. So it goes through at minus 2, so a bit messy there. Right, so it is a cubic graph. We can see if we multiplied that out, you would get cubic. Now, if it goes through 0 on the y-axis, that is our y-intercept. We don't need to worry about that. So it's going to be something along these lines, go through there, and come through here. Right, now, this setup, you can see what we've got here is what you call a repeated root. Now, if you don't like the way that's written, let's do this just to highlight what's going on. We'll do the same thing. Now, it's going to go through at, that will be a 2, let's say a 2 here, but we've got minus 1. Now, the issue is, you go, well, we've got minus 1 twice. Well, that means it just touches at this point. We've also got, we know it's a cubic because it's going to be positive, so this type of graph. So it's going to have this kind of format. The next thing we need to think then is what will the final value be? Well, we've got minus 2 times 1 times 1. So it's going to go through at minus 2. So that means the graph comes up here, touches there, and comes down. Now watch this. So we're going to go touch there. Now I'm going to do this on purpose. I'm going to go through there and back up. It'll go like that. Now I've deliberately made sure that I didn't come through and make a turning point on the y-axis. Many students do that. It could be true, but we don't know that to be true, so we need to just make sure it's not obvious.